Good afternoon. Everybody hear me okay? Got a microphone on? I'm not generally one who needs a microphone, but I thought it would be prudent with such a big crowd today. So as Craig mentioned, I'm with LogixWISE right now, but that's been an event of about 3 weeks. So prior to that, I was with American Axle Manufacturing, and we've got about 35 manufacturing sites globally, plus engineering. And my responsibility was controls engineering technology. So I managed anything from safety to clickety-clack all the way up to plant floor networks to security to how we move data from the plant floor to the enterprise. Do I need to do something here? I mean, I'm technically challenged when it comes to office equipment, but this is not me. I used to tell people, give me $30 million worth of automation, I can have it running quick. Give me a copier or a fax machine and it'll beat me down every day. Yeah. So we'll start without it. So what I want to talk about today is one of our major undertakings at AAM here recently. I say recently, it's been going on for probably a year or so in total, is we have two things we need to do. We've got some really old legacy equipment, and that's predominantly CNCs from a machining perspective. So we've got, I don't know, I'll ballpark it, say 1,100 CNCs globally. We also have, from an assembly systems perspective, dozens of assembly systems per plant globally that build axles, right? So everyone thinks the axle is a bunch of gears. Actually, they're pretty complex. There's 90% of them have electronics, and over 90% of the products we build. So with that, we need to collect a lot of data. We have a lot of requirements from our customers' perspective. So we started a project, and right in the middle of it, and I know no one as an end user can appreciate this because it rarely happens outside of American Axle, right in the middle of this massive project, they changed the scope a little bit. Management said, what we could do, and this would be great, Jeff, so I'm sure you can fit it into the timeline, is take all 1,000 CNCs and get data from those too. And I said, you mean the 30-year-old ones with no Ethernet or any connectivity whatsoever? Yeah. I went, oh yeah, that's going to be a piece of cake. Sign me up for that one, and I'll get her done in the same time frame. No problem. So now all of a sudden my problem became, how do I talk to our recently past, recent, or current stuff? How do I talk to 30 years old? More importantly, how do I do that in such a way as I don't have vastly separate systems on the plant floor, right? I can't do that to my maintenance. I can't do that to my plant engineering. I mean, I was plant engineering for a lot of years. I would have been really mad at me had I done that to me when that was me, okay? So I had to start looking for something that would do both. And the first thing I'm going to address is, how did we talk to those 30-year-old CNCs? Because obviously, that's a bigger challenge, right? A lot of companies have a lot of solutions for that, the newer stuff. Not many have solutions that can go back and by leveraging this IoT we talk about, actually get that data. Hey. All right. Now, assuming I know how to work this, yeah, so on this legacy equipment, what were our goals? Now, first of all, I tend to talk fast, and I talk a lot faster when I'm speaking. In fact, I'll burst up to 4,000 words a minute. So if I get going too fast, somebody go, and I'll slow it down. I've got 20 minutes. I thought I had 30. Actually, I thought I had 2.5 hours, but apparently that wasn't true either. So I'm gonna sort of stick with the slides, but we're gonna sort of not. Okay? So let's talk about the legacy equipment. What did I have to do with it? What did they want out of this? Well, they wanted to increase accuracy of part numbers. Right now they have guys that go over to a machine every hour and go, I made 27 good ones, even if he made 8. Because of course he's not going to indicate that he didn't make the 27 they expected him to make, right? Well, that's a problem. Downtime events. Well, then you get guys that will say, I didn't make my 27 parts because the machine was faulted for 2.5 hours. Really? Unfortunately, we have no record of that because there's no connectivity to that machine. And how do we do time-based information such as part-to-part cycle? How do we get FTQ out of that? How do we calculate OE? Well, if you're trying to get part-to-part cycle times and the thing was faulted, right, that's a problem. But more importantly, the first thing we noticed when we actually implemented this system was, why did the guy on first shift take him 27 minutes to unload and load, and the guy on second shift was 1 minute and 23? That was kind of the first news or heads up to management that, hey, this is actionable data. We can do something with it. It might not be the guy's fault. Maybe he's not got dunnage, maybe, but there's something in the process. We've got a ticker now that tells us there's a problem. What was the challenge though? So we've got all these systems out there. They run, they make production, right? In the world of manufacturing, which is somewhat contrary to what happens in the IT space occasionally, we don't change things that aren't broke. We don't want to get in and muck around with a program or dink around with wiring if we don't have to. If it works, don't fix it. Okay, sometimes in the IT space, we can make it work better, so we'll do new stuff. Okay, but there's less impact of actually parts out the back door when you do that. It's got to be maintenance friendly. So the next challenge was, how do we do this in such a way that our maintenance team has a prayer? So what I wanted was a solution that was essentially just an IoT type of device just hanging there. No real IP inherent in it, very little in the way of any kind of configuration. And I wanted it to send data out, okay? That's different. There are companies out there today that have solutions for CNCs, but it's a big sizable piece of equipment. There's lots of connectivity, it's got lots of configuration, and it's got lots of requirements from a maintenance perspective. And then I ended up with a box about this big, and it's very, very, very low maintenance. So I was looking for something like 32 discrete I/O. I wanted some relay inputs and outputs, and I wanted some analog. Now, so I get the question all the time, well, couldn't you just put Ethernet on that? Well, sure, not a problem. It's $10,000 for the adapter, because we haven't made them since 1926. And it's going to be 10 meg half duplex. Any problem with that at all? Any problem at all? Maybe a smidge. Right? You think anything else is to sell? I'll talk to IT about that. Yeah, I'd like to put that 10 meg half duplex thing in the network. Are you guys okay with that? No, strangely they weren't. So that's not really an option. Another big problem I have is, do we go wired or wireless? Well, wireless in controls is a touchy subject. It's a philosophical or almost religious argument these days, right? But with CNC equipment, they tend to move it a lot. So they'll take a piece of equipment and move it across the plant. And 6 months later, they'll move back. And then 4 months later, they'll move it this way. And that's pretty much true of all the automotives. Well, at $1,500 a drop, the cost of that gets kind of cost prohibitive if we start moving equipment, especially when you think about doing 1,000 of them. That globally, that gets pretty expensive. So the solution needed to be wireless. What are the problems with wireless? Well, number one, the IT guys looked at me and said, wait, we don't have the Wi-Fi infrastructure for that. I mean, we have 100% coverage, but think of the access points we're going to have to add. Think of this, and think of that, and it's going to have to be 5 gigahertz, and we're going to give you 3 channels only, and blah, 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 blah. So how do I do it without impacting that, okay? Well, I need to design it for low bandwidth. It's got to be extremely low bandwidth. Meaning I don't want something sitting pulling it, talking to it consistently. I don't want continuously open TCP connections that are just chunking data back and forth. I don't want the device at the other end spewing data across wireless. I can't have it, it won't work. I can't put 220 of those in a single plant on the existing Wi-Fi infrastructure without having to change it. I have a solution. The solution we came up with will do that because it's negligible bandwidth. In fact, when we tested it initially, my IT guys thought it was broke. Thought it didn't work because the amount of information coming out of it is exactly what needs to come out, no more. So we cooked up a box working with Telit and their deviceWISE for Factory team. So we cooked up a box about this big. It's got everything I described. It sits there quietly. As there's any state changes on the machine, it sends out a packet to deviceWISE Enterprise. It sits up in my server room. So I have one server sitting there, and it's not doing a lot either until a packet shows up. they've got this beautiful unsolicited functionality. So the sensor just listens for a packet from one of these boxes, one little packet. Gets that packet, does something with it, right? Gets a state change. Basically, it turns bits on and off on the deviceWISE enterprise side. So I've got a single server instance doing 300 boxes easily in one little VMware instance, and I've got boxes on the floor that are virtually silent unless something happens. The impact to the existing infrastructure is negligible to none. Okay? That was a huge requirement. And then we pump it off into our homegrown IPF system, which is a plant floor FIS type of reporting. So that worked for us, works very well, right? We've got 500 of those on site now. We'll have another 500. So what I'm talking about isn't vapor, it's not a dream, it's not a thought, it's a hey, I'd like to do it, so we've done it, it works, and it's in production. It's low cost, comparably, it's a heck of a lot lower than that $10,000 Ethernet card. And it meets all the requirements that the IT guys think it's the coolest thing since sliced bread, but it's industrially hardened. Does all my 24 volts DC, AC, whatever I want, okay? So the second piece of this puzzle is, how do I have the same interface and collect data from all my current stuff? So we're predominantly Rockwell, but we have lots of Siemens in places. We have lots of, I don't tell them that I know this, but I worked for Modicon for 15 years, so I never mentioned that, because we had Modicons out there across the globe. So how do I connect all those separate systems? Or maybe it's something as simple as sensors, right? Maybe in our heat treat, we've got some sensors that we want to pump data into a process database. We have a big project going right now where we're retrofitting all of our process systems in terms of heat treat. Oh, look at that, there's a clock right there. Way ahead of me, right? So how do I get data into those systems like a historian? How do I get data into SQL Server, which is our predominant database that we use? How do we interface to Oracle? How do I connect to these CNCs on the plant floor and get that data? How do I do all of that and maintain a consistent, easy to use environment? Once again, we turned to Telit and said, hey, this is what we want to do, and deviceWISE seems like it's the answer. So we started going down that road. We had an existing system, had this list of problems. So these were all things we had to overcome, right? I'm not going to read them all to you, but I mean, none of those look exciting, right? I'm kind of a security proponent. The last couple of times I've talked to ARC has been on plant floor security and what we do in that space. So not having that, not having any multiple threaded processing, lots of things like that, that was a problem for our existing system. It cost us time. And when you're dealing in building parts, time is money. Every part takes, every 20 seconds longer to build a part is a big impact on your bottom line. Right? We were using issues with this. Solution we had beat the beans out of our PLCs. So what we look for, and what Telit delivered to us in terms of deviceWISE, is a multi-threaded, multi-pooled application that completely isolates the rest of the sentence which I cut off from my slide. So, delays in pending transactions, on-the-fly changes, user interface. So it gave us a lot of stuff we didn't have before, which applies to that CNC solution as well. Logic engines, role-based security, logging and diagnostics, new OPC, DA, UA, whatever we need if we have to talk to existing legacy OPC. One of the things we always have the capability, or we have the capability for here in the short term, is MT Connect. So when we get newer CNC equipment in, and we want to talk using that methodology, that won't be a problem. We'll drop right in. And the existing functionality stays the same, the interface looks the same, it feels the same, it works the same. My learning curve is down, the ability to maintain it is up. So, one of the problems we have is on the existing stuff that's not, I mean, that we actually can talk to over Ethernet or Fieldbus. I needed something to talk to that. Right? So we needed Ethernet IP, Profinet, MT Connect, DA, UA, client server, blah, 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 lots of others, scattered ones throughout the mix. All right? So with deviceWISE, we had all that capability. So we could talk to the Atom box, we call it, or the CNC box, or we could talk to the existing control controller. So now, what did that get us? Well, the stuff that management likes the best is we had immediate return in decreased loss production. Because the environment is bulletproof, it's stable. We have systems that we literally remoted across the globe to install, never restarted the computer or whatever it was that was running deviceWISE, and they still run today, and they've never been stopped, started, or rebooted. Okay, so it just runs. We were able to decrease the first three. The second three, the improved throughput, we saw improvements in cycle times immediately. So transactions that might take half second or a second now took 100 milliseconds, 50 milliseconds, 30 milliseconds. In fact, some of them were so fast we couldn't measure them with the PLC because the transaction exceeded was less than the scan time of the PLC. So the fastest I could ever get was one scan of the PLC. Okay? Tack time, average of 50 parts per day more off some lines. That's pretty significant per shift. Future cost avoidance, that's another big metric we look at. What will this save me down the road? Well, we removed a panel per line. I don't need it there anymore. That was about 45 grand a panel per line, so that's huge. Existing lines can be converted. So with the flexibility in deviceWISE, we've got this logic engine in there. We had guys that went out and kind of, I don't want to say that they did bad things, but let's just say they added their own particular unique flair to how we were getting data in the previous system, which sort of deviated from the way it was supposed to happen, so we had these one-off configurations that were unique. With deviceWISE, we were able to match how that worked because it's got the ability to massage and manipulate the data as it flows through. No other solution we found had that ability. That was critical to the success because we didn't take anything out of production to do this. We shut one thing down at a time, brought the new one up. Per station on an assembly line. If I have 60 stations, took one offline, brought the new one up. Took one offline, brought the new one up. Made a big difference. We eliminated licensing. We eliminated plant floor PCs. Some of you may or may not have seen previous presentations. I've got a slide that says friends don't let friends put PCs on plant floor network. Right? So it's been a mission in my life to remove them. Flexible, scalable, and immediately cloud ready. So I've got a manufacturing site in Indiana that has 7 machines. I don't have an IT infrastructure there. I don't have servers and all the kind of things that I have in larger sites. So what can I do? Well, I can drop deviceWISE on that, and I push it up to the cloud and back down to one of those sites. I don't have that option with anybody else's solution today. Going all the way back to that simple little box that we created and giving me the same platform across all of it. The same look, the same feel. So nobody else I've been looking for years. Doesn't exist. External analytics. So it feeds our analytics engine. We've got a big project going right now where we're starting to delve into analytics. So while deviceWISE itself doesn't do analytics, it's the perfect funnel to feed data into an analytics system. Populate the database we need to mine the beans out. Right? When we did this, it had to be smooth and bunkless. There was no option. And we shut down, we're a just-in-time supplier. That means parts come off the end of the line, they get put on a truck, they get delivered to the customer, such as General Motors, Ford, or Chrysler. If we don't deliver, they don't build. It's about $18,000 a minute. I chuckled, somebody told me if you shut down a 300 millimeter fab machine at Intel, it's about $250 an hour. I laughed. I said, really? I would have thought it'd be a lot more than that because if I shut down GM for an hour, it's about $1 million. So this is kind of my picture of the plant manager and the plant engineer, former engineer. So that wasn't going to be me. So the solution that we put in had to allow me to do this in a bumpless transition, and we had that. It worked perfect. We've had absolutely no downtime attributed to this. We started converting everything globally, including putting 500 of those boxes on the floor, and with plans to do another 5. But again, I can't say enough. From a customer perspective, it's been an excellent project from both the CNC side as well as the more legacy or more mainstream equipment and getting data and stuff off of it in complete, consistent, concise. That's all I had.